Hello everyone. Today I'd like to show you a very useful module. It's a buck converter with an extremely wide input voltage range. It can handle input voltages of up to 150 volts and deliver output currents as high as 40 amps. Here, I've connected the input of this buck converter to a 450 watt solar panel. The input current is currently 6.3 and as you can see, the output current has increased to 15.5 amps. You can use this module as a battery charger or for any other application that requires a high output current. So, let's get started with the project. This video is sponsored by JLCPCB, one of the leading companies in the PCB industry. I'm truly grateful for their support. Many of my projects wouldn't be possible without their help behind the scenes. Right now, JLCPCB is offering a special promotion for new customers. Be sure to sign up using the link in the video description below and claim your discount today. Normally, you'll receive your PCB within 2 to 3 weeks, depending on your location. This PCB design includes 4 cutouts, one on each side, because I want it to fit perfectly inside my ABS plastic enclosure. If you don't like this design, you can easily modify the PCB to suit your own requirements. These are the input and output filter capacitors for the circuit. Make sure to choose capacitors with voltage ratings that are suitable for your application. In general, the larger the capacitance, the better the filtering performance. The same applies to the diode and MOSFET. Choose components with voltage and current ratings that are as high as your budget and application allow. In this build, I selected a 60A diode and a 250 volts 59 amp MOSFET. Also, don't forget to add a fuse at the output. A fuse is a very inexpensive protection device, but it can be extremely effective in protecting your circuit from damage. This 30A relay is used to disconnect the charging output whenever there is no PV input voltage. The buck inductor is wound on a blue toroidal core with a diameter of 4 centimeters. If possible, use multiple smaller copper wires twisted together when winding the inductor. This helps reduce losses and keeps the inductor cooler during operation. In this build, I used 2 1mm copper wires wound together to make the inductor. This small module is based on the UC3843 controller. I purchased it as a ready-made module from a local electronics store. If you can't find one, I also have an alternative version that uses discrete components instead. This is the first test. The weather was quite cloudy, so the solar panel wasn't operating under ideal conditions. I connected the buck converter to a 450 watt solar panel and used a small battery as the load. At this point, the charging current is around 6 amps, while the input current from the solar panel is about 2.4 amps. As the sun came out a little more, the output current immediately increased to 15.5 Vatt. The circuit is running very smoothly and remains quite cool. The heatsink temperature is only around 40 degrees Celsius.